Yeah, now it's time to explore our F tests. So we will begin with one-way ANOVA F test. So we will take a practical example and understand how to leverage ANOVA one-way ANOVA F test to do the feature selection where the categorical and continuous variables get involved. So a real world example that we are going to demonstrate and how to test the statistical significance of the relationship between continuous variable and categorical variables using the one-way ANOVA F test. To put it in simple words, we're gonna do feature selection using one-way ANOVA F test where the categorical and continuous variable is got involved. So let's begin with the first step. Our first step is the problem statement. The objective is to identify the most influential variables in predicting purchase behavior across different product categories in an e-commerce website dataset. So we want to determine if there is a significant difference in the mean purchase amounts across different product categories. So now let's move on to the second step. It's load and prepare the data. So let's see. Yeah. So importing the respective libraries and modules will be done. Import pandas as pd, then scipy.stats as stats. Done. Now it's time to load and prepare the data. So the data set is loaded into a data frame. So, and then which contains the variables. So let me call up that. It's df, and this data set consists of this data frame, contains the variables product category, purchase amount, customer satisfaction, and shipping speed. So the data should be properly cleaned and prepared, ensuring there are no missing values or outliers. And we have ensured everything, and we do not have any missing values or outliers or duplicates. And here is the data. Other than purchase amount, this is numerical. Other than that, rest all are categorical data. So that's what is our second step. Now let's move on to the third step, which is define the hypothesis. Here the null hypothesis states that in this example the null hypothesis states that there is no significant difference in the mean purchase amounts across different product categories. So the alternative hypothesis assumes that there is a significant difference in the mean purchase amounts across different product categories, and that's what we have formulated the null hypothesis. Okay, so now let's move on to the next very important step, which is step 4, step 4 is nothing but perform one-way ANOVA F-test. So here we're going to perform the one-way ANOVA F-test between the independent variable and dependent variables. Okay, so independent variable. So let me write it down here. So features, this is my dependent variable, target variable. So target variable is purchase amount. On the other side, I have my independent variables, which are features. So product category and any other each potential predictor is basically our dependent variables, such as customer satisfaction and shipping speed. So these are my features, and this is my target variable. So hence my system is pretty ready for the action with ANOVA, one-way ANOVA F-test. So this assesses the statistical significance of the relationship between the independent variables. This one, these independent variable and each predictor. So we'll have this independent variable, and this is nothing but your predictors, and this is our target variable. So this is going to explore, this is going to assess the statistical significance of the relationship between these two. So we'll have a three combinations, one, a two, and three, and that's what is going to happen next. And that's what we do in step 4. Now let's get back to the step 5. So step 5 for us is to calculate the F statistic and a p-value. So calculate the F statistic and p-value for each one-way ANOVA F-test. So the F statistic measures the variation between group means compared to the variation within each group. So the p-value represents the probability of observing the obtained F statistic, or an even more extreme value under the assumption that null hypothesis is true. So this is math statistic as we have discussed earlier, and even we got the degrees of freedom here. So, and this is what the overall what is F statistic. But we won't be calculating manually. We are going to use stats, a SciPy library and stats module, and from stats module we're going to call up stats dot f underscore one-way method to calculate f value and p value, and that's what we're going to do. At the same time, we will also calculate the degrees of freedom, and in addition to that we'll be calculating z critical also. So that's what it's a long step. Let's do that. So significant features, the square bracket that I have taken, and this is my alpha, this is my significance level. Let me put it here. That's okay. I'll keep it here. So let's begin. So I have to calculate f value and p value, and these things I can calculate from stats module f underscore one-way method, but inside that I have to give the which is the target variable and which is the feature. So I've taken the target variable. Target variable was decided, it's a purchase amount in all the cases. So total we have three cases. One is purchase amount and product category. So that's the first one. So you see that zero index, that's this one. Then target variable with the customer satisfaction, index 1. Then target variable with the shipping speed, that's index 2. So that's what. So we'll get the f value, observed f value with a respective combination for purchase amount and purchase customer satisfaction, purchase shipping speed, and similarly we'll get the p value. In addition to that, I want to calculate the degrees of freedom. To calculate the degrees of freedom, so number underscore groups, so length of features and length of the overall target variable, so both, and with that you'll get the df between is nothing but your number of groups minus 1. So it's 2 because we have 3 groups. 3 uh, if you take a product, again it varies. Let's take a product category. It consists of 3 groups. 3 groups minus 2, you'll get a 1. And that's the reason you have directly mentioned the feature. So with every one, it's gonna vary. The critical f critical is gonna vary with respect to that df between and df within. Okay, so here we got the df between, number groups minus 1, and df within is numbers of samples minus number of groups. So we have total data set of 1 2 3 4, it's 9. 9 minus 3 will get around 6. So that's what df between and df within. We have done the manual calculation. Now we can calculate the f critical manually. But again, manually doesn't mean you'll be doing that. We'll directly call up call F method and PPF, and there will be giving a respective arguments 1 minus alpha and DF between and DF within, which will give you the F critical. Okay, so that's it. Let's get back to the next step. So now it's time to set a significance level. So a significance level, alpha is chosen. Alpha is chosen. You see that alpha is chosen as the threshold to determine the statistical significance. In this case, a significance level of 0.05 is used, meaning that a value is less than 0.05 indicates a statistical significance. So this is what we have chosen. So now once it's done, I have to uh, once the statistical significance value was given, now it's time to apply the condition. So that also should be put in the loop so that it will be repeated for everything. So if p-value is less than alpha, then the significant feature should be append, or else it should not be. It should be removed as removed from the significant features bracket. And let me execute and see. And here it is. So all set, all done. Now it's time to interpret the results. So interpreting the results. So uh, we examine the calculated p-values for each one-way ANOVA F-test. If the p-value is less than the chosen significance level, it indicates the statistical significance. So variables with p-values below the significance level are considered statistically significant predictors. So here the calculated f values and p values for each one-way ANOVA F test are printed, that you can see on the screen here, printed. Even the critical values were also printed. It indicates statistical significance. So variables with p-values below the significance level are considered statistically significant predictors. Now let's try to have a visual intuition of the respective process, that's interpretation. So this is what we got. So we have a degrees of freedom, so df between and df within. So if you want to see, I'm going to call up, so print df between, which is 2, and print df within. Yeah, so it's 6. So 2 and 6, that's what I'm going to take up here in this condition. So now let me come here. So let's give 2 and let's give 6, and this is what we got. And of course we are doing the right tail. So my f is equals to the critical value. Critical f is 5.143 because my p value, the alpha, a level of significance is 0.05. Okay, so now this is my rejection region. So with respect to this, I'm going to compare. So let's get back to our slide and let's have a clear-cut visual intuition. Okay, so the same graph is here. So with the level of significance 0.05 and f value is 5.143 with respect to degrees of freedom, a right tail test. And this is our rejection region. Okay, now let's see the first case. So our first case is f value, the observed f statistic is 1.207, somewhere it falls, and the p value is 0.362. So we at this moment, let's keep the p value aside. Let's compare the f value. So f critical is 5.43. Right of 5.43 is my rejection region and left of it is acceptance region. So as my f value is lesser than the f critical value, so it's not falling in the rejection region, hence I'm a fail to reject null hypothesis. And that's what is, when I fail to reject null hypothesis, there is no significant relationship between product category and purchase amount, so I will rule this out. So what's next? And the second one is here. So I have an ANOVA F-test between the customer satisfaction and purchase amount. Same. I have the same rejection region, and then so my F value is by and large same 1.207, the before 1.208, and of course the p value. Again, I'm not using the p value. So if I use F value itself, my F value is lesser than the critical F value, or in other way, my observed F value is not falling in the rejection region. So I fail to reject null hypothesis. Hence, there is no statistical significant relationship between the customer satisfaction and purchase amount. This is with respect to the F values. You can tell the same thing with respect to the P value. So my P value is 0. My P value, observed P value is 0.362, whereas a level of significance is 0.05. As per the condition, if my P value is lesser than the alpha 0.05, then it is statistically significant. But here my p-value is clearly greater than 0.05. Hence there is no significant relationship between customer satisfaction and purchase amount. Hence I'm going to rule this out too. So the last feature that I have, let's see what's going to happen. So this is between shipping speed and purchase amount. If I see my F value, my observed F value is 5.96, which is by and large closer to the 6. So if I see my 6 value, which is falling into the rejection region, you can clearly make that out. It's falling into the rejection region. Hence we reject the null hypothesis. When you reject the null hypothesis, there is a significant relationship between shipping speed and purchase amount. This is with respect to the F value. Now we will work this out with respect to the probability value. So the observed P value for the F is 0.037. Our level of significance is 0.05, which is clearly lesser than 0.05. So your 0.037 is lesser than 0.07. What does that mean? When your p-value, observed p-value is lesser than the level of significance, we say there is a statistically significant relationship between those variables, and that's the reason we say that there is a significant relationship between shipping speed and purchase amount, and that's what is output. I got it here. You see that? And that's what I got. And I have printed the significant features. I got the only one significant feature, that is a shipping speed. So because that's the only one is basically uh, agreeing, that is the only one which is agreeing the condition with p-value less than alpha, or falling into the rejection region. Hence the shipping speed has been selected as a feature, as a significant feature. I ruled out other features which are product category and customer satisfaction. Obviously the shipping speed makes more sense than compared to the product category. Hence I'm gonna select this feature. This is how you select the categorical features with respect to the continuous target variable. So let's continue back to the next step. Okay, so next step for us is step 8, which is perform post hoc analysis. This is very important step. Post hoc analysis is nothing but if one-way ANOVA F-test indicates a significant difference among the groups, you can conduct a post hoc tests to determine which specific groups differ significantly from each other. So this step helps identify pairwise difference between groups. So what we're going to do, we are going to use post hoc tests such as two-case honestly significant difference test or Bonferroni correction, so which can help determine pairwise differences between groups. So that's where, so this is going to be the introduction to the two-case honestly significant difference test. Okay, so we'll be covering up this in forthcoming slides, but you should understand now itself. So why do we require HSD test or two-case HSD test? Okay, then step 9, perform feature selection, that we have done it. So based on the statistical significance test results, the significant features are identified. So in this case, the product category variable, and we also have a purchase amount, and we have total 3 features. Out of that, the shipping speed has been selected as a feature. Then once you have identified the final step, future further analysis, once the statistically significant features are identified, you can perform additional, such as a regression modeling, classification, or other machine learning techniques using these selected features to build predictive models for purchase behavior. So by following these steps, and analyzing the obtained f values and p values, you can determine the significant features in predicting purchase behavior across different product categories in the e-commerce website dataset. And this is how we leverage one-way ANOVA F-test to do the feature selection with respect to the continuous and categorical variables.